11.3 talks about something called expected value. Okay, so let's see what it says here. It says expected value, otherwise known as the expectation, is often used to determine the expected results of an experiment or business venture over the long term. So this is part that's real important. People use expectation to make important decisions in many different areas. Let's see. For example, expectation used in business to predict future profits of a new product. Insurance industry uses expectation to determine premiums, so insurance companies can make a profit. And expectation used to predict the expected gain or loss in games of chance. Okay, so I'm going to kind of skip over this piece here so we can get to our first problem. Okay, so I am going to look at this paragraph right here though, and it says the expected value E is calculated by multiplying the probability of an event occurring by the net amount gained or lost if the event occurs. If there are a number of different events and amounts to be considered, we use the following formula. Okay, so here's my expectation or expected value formula. The probability for the first event times the amount we're either going to win or lose, plus the probability of the second event times the amount we're either going to win or lose, so on and so on and so forth. This here just refers to the nth event. Now the nth could be the second, it could be the eighth, but it's just, that particular event, the last event. So let's take a look at the first problem here. It says JetBlue Airlines is considering adding a route from Boston, Minneapolis. Before making a decision, the company needs to consider many factors, including potential profit or loss. After considerable research, JetBlue estimates that if it adds the route, there is a 60% chance of making an annual $800,000 profit, a 10% chance of breaking even, and a 30% chance of losing $1 million. How much can JetBlue expect to make annually on this new route? All right, so let's go ahead and find using our formula. Okay, so the probability of the first event is 0.60 because it's a 60% chance. In this case, they're going to make a profit of $800,000. So I'm going to take that number, we're going to multiply it by $800,000. Okay? The second probability is a 10% chance. So as a decimal, that's 0.10, and it says they're going to break even. So think about what breaking even means. You didn't win any money, you didn't lose any money, you have a gain of 0. Okay? And then a 30% chance of losing $1 million. So guys, because that is a loss, I need to think about that as a negative $1 million, okay? All right, so now what we're going to do, let me grab my calculator right here and turn it on, clear it out. Okay, so we're going to take 0.60 times 800,000, okay, plus 0.10 times 0 plus 0.30 times negative 1 million. And hit enter. So our expected value is 180,000. So over the long run, they can expect to make $180,000 a year on average, right? Okay, so let me scroll down to the next problem and let's take a look, see. So we have, it says, Maria has taken a multiple choice exam in which there are 5 possible answers for each question. The instructions indicate that she's going to be awarded 2 points for each correct response and that she's going to lose half a point for each incorrect response. No points will be added or subtracted for answers left blank. If Maria does not know the correct answer to a question, is it to her advantage or disadvantage to guess at an answer? Okay, so if we think about this, it says that there's 5 possible answers, okay? So we think about that, answer choices A, B, C, D, and E. There's our 5 choices, right? But only one of them is going to be correct. Okay? So the probability of getting a correct answer is 1 out of 5. The probability of getting it incorrect is going to be 4 out of 5. Okay, so the question says, if she does not know the correct answer, is it to her advantage or disadvantage to guess at an answer? Well, let's see. The probability that she guesses correctly is going to be 1/5. Okay. If she guesses correctly, she's going to gain 2 points. Now, the probability that she's going to guess incorrectly would be 4/5, and in which case she's going to lose half a point. Okay. All right, so now let's go ahead and do our calculations. So guys, I'm going to think of this 2, number 1 is 2 over 1. Multiply straight across, that's going to give me 2 over 5. Okay. Multiply straight across, that's going to give me a negative 4 over 10. Okay. We need to get a common denominator, so the common denominator between 5 and 10 is in fact 10. Okay. So we had to multiply this one by 2, so that's going to give me a 4 there. We didn't change this one, so we're not going to change that one. We add them together. 4 plus negative 4 is 0 over 10, which is the same thing as 0. So is it to her advantage or disadvantage? It doesn't matter, right? Over the long run, it's not going to make that big of a difference. Okay. So now there is a part B. Okay, so let's take a look at part B. It says if she can eliminate one of the possible choices, is it to her advantage or disadvantage to guess at an answer? Okay, so suppose she can get rid of one of the answers. Okay. Well, now the probability that she's going to guess correctly would be 1 out of 4, and incorrectly would be 3 out of 4. So let's find the expected value for her to guess. Okay, so the probability that she guesses correctly is 1/4. Remember, she gains 2 points. Guys, I'm going to think about that as 2 over 1. The probability that she guesses incorrectly is 3/4. She loses half a point when that happens. Okay. So again, if I multiply straight across, let's see. That's going to give me 2 over 4 plus a negative 3 over 8. Again, I need to get a common denominator, which in this case will still be 8. Okay. So multiplying this one by 2 and this one by 2, that's 4 over 8. I'm going to leave that one alone because we didn't change that 8 there. That's going to give us a positive 1/8. So is it to her advantage? Yes, it is. Every time she guesses correctly, on average, she's going to gain 1/8 of a point. Okay. Now, remember what we said earlier, that the expected value is sort of the long-term type thing, right? Okay. What we mean by the long term is if she continues to do this over the long haul, if she were to guess, say, on average, on 8 questions, she would gain 1 point out of doing that 8 times, okay? So, again, this is what expected value means. It doesn't mean this is what you're going to get every single time, but over the long run, this is what's going to happen. Okay? So, let me keep scrolling here so we can try to take a look at the next problem. Again, these are all expected value. They're all going to be done the same way, okay? For an outdoor concert, event organizers estimate that 20,000 people will attend if it's not raining. 12,000 people will attend if it is raining. On the day of the concert, meteorologists predict a 30% chance of rain. Okay, determine the expected value of people who will attend this concert. All right, so we know that the probability that it's going to rain is 30%, which is 0.30. So the probability that it's not going to rain would be the complement, which is 1 minus 30% would be 70%. So now let's find our expected value. Okay, 20,000 people are going to come if it does not rain. Well, if it does not rain, there is a 70% chance we can expect 20,000 folks. Okay. If it does rain, there's a 30% chance of that. We're only going to expect 12,000 people. Okay. So now, I'm going to do the same thing we did before. I'm going to grab my calculator right here. and do our calculation. So 0.7, oops, turn it on. 0.70 times 20,000 folks plus 0.30 times 12,000 folks gives us a total of 17,600 people. This is on average how many people they can expect, okay? They might get more, they might get less, but this is the average, okay? All right, so let's take a look at the next problem here. It says, when Josh attends a charity event, he's given a free ticket for the $50 prize. A total of 100 tickets are going to be given out. Determine his expectation of winning the door prize. Okay, so I don't know if y'all caught the Super Bowl, if y'all caught the halftime show. Let's use J-Lo. Okay, when J-Lo attends a charity event, she is given a free ticket for a $50 door prize. A total of 100 tickets are going to be given out. Determine her expectation of winning the door prize. Okay, so I'll tell you what, I got a question on J-Lo. So J-Lo and I go to this charity event, and I tell her, boo, because that's what I call her, we're going to get that $50 door prize. So I go over there and I block everybody else from coming in. J-Lo's going to go, she's going to get all 100 tickets, okay? We want to figure out her expectation of winning the door prize. All right, so let's go like this. We know we have 100 tickets. Suppose the tickets are marked like this. Okay, there's 100 of them. The probability that we're going to win is 1 out of 100 because there's one winning ticket. Okay? The probability that we're not going to win, well, if one of them is the winning ticket, the other 99 aren't. Okay? All right, so let's find our expectation. Okay, the probability we're going to win is 1 out of 100. And if we win, we get 50 bucks. Okay? The probability that we're not going to win is 99 out of 100. And if we don't win, nothing happens, right? We don't get any money, we don't lose any money, it's 0. Okay? So let's take a look here. We're going to multiply. That's going to give me 50 over 100, which is the same thing as 0.50. Okay? Guys, in terms of money, this is 50 cents. Okay, so let's think about that for a minute, okay? If I blocked everybody else from going to this charity event and I told my boo J-Lo, girl, you go get that winning ticket, right? She's going to get all the tickets because she's the only one who's there, okay? So she gets all 100 tickets. So then when they call out ticket number, oh, I don't know, 47, which happens to be the winning ticket, she's going to say, oh, look, that's me, right? She's going to get her 50 bucks. But think about how many tickets she got. She got 100 tickets, right? Out of those 100 tickets, she won $50. It tells us on average each ticket basically gave you about 50 cents, okay? Because she had all 100 of them, okay? But that's in essence what expected value means. Okay? Now, let's look at the next one. And we're going to stick with J to the hello, hello. Okay. So when J-Lo attends a charity event, she's given the opportunity to now purchase a ticket for the $50 door prize. The cost of the ticket is $2, and 100 tickets can be sold. Determine J-Lo's expectation if she purchases one ticket. Okay, same thing as we did before, right? We still had our tickets like this. Okay, so the probability of winning the ticket still 1 out of 100. Probability of not winning a ticket, still 99 out of 100, okay? So let's find our expectation. Okay, the probability we're going to win is 1 out of 100. Now, let's figure out how much we're going to gain. Okay, so I want you to be aware there is a $50 door prize. But in order for us to get the ticket, we actually have to pay $2. So you don't really win $50. You really win only a total of $48 because it costs you $2 to play the game. probability we're going to lose, still 99 out of 100. And if we lose, what happens? Well, we lost our $2 that we spent on that ticket, okay? So now we're going to go through this here, and we're going to say 48 over 100 plus, let's see, 99 times 2 should give us, I want to say it's 198. But let me double check. Yep, 198 with a negative over 100, okay? When we add those two together, let's see, that should give me something like negative 150 over 100, which is negative $1.50. Okay, let's think about the same scenario that I described a little while ago. So J-Lo and I go to this charity event. I block everybody else from going in there. Say, boom, go get those tickets. Look how many tickets there are. There's 100 tickets, and they cost $2 each. So if J-Lo wanted to get all those tickets, she would have spent $200, right? But the prize is only $50. So she's still in the hole $150, right? Because it cost us $200 to get those tickets. We bought all 100 of those tickets, so on average, we lost $1.50 on every single ticket, right? Okay, so let's go to the next problem. Hello. All right, so it says 1,000 raffle tickets are sold for $1 each, a grand prize of $500, and 2 consolation prizes of $100 are going to be awarded. The tickets are placed in a bin, and the winning tickets will be selected from the bin. Assuming the probability of any given ticket for the grand prize is 1 out of 1,000, and the probability of that any given ticket selected for a consolation prize is 2 out of 1,000, determine Irene's expectation if she purchases 1 ticket, and what happens if she purchases 5 tickets. Okay, so we have 1,000 tickets, right? 1,000 tickets. Okay, so the probability that we win the big prize, okay, I'll put like this, B for the big prize, 1 out of 1,000, right? The probability that we win the consolation prize, because there are 2 of them, is 2 out of 1,000, okay? Now, what's the probability that we don't win anything, no win, right? Well, if there's 1 consolation, or 1 main prize and 2 consolation prizes, that means that there are 997, that's a 7, that don't win anything, okay? All right, so let's do part A. So part A, Irene's expectation. The probability that she's going to win the big prize is $1,000. The grand prize is $500. Okay. But remember, Irene had to spend $1. So if she wins that, she's really going to win $4.99. Okay. Now, the probability of getting the consolation prize is 2 out of 1,000. Those prizes are $100, but again, she paid $1 to get the ticket, so she's really going to win 99 bucks. Okay. The probability that we're not going to win is 3 out of 1,000. And the only thing that's going to happen is we're going to lose the $1 that we spent. Okay. So now I'm going to go ahead and multiply straight across. It's going to give me $4.99 over 1,000. 2 times 199, I believe earlier I said it was 198 over 1,000. This was not 3. Why did I put a 3 there? Sorry, guys. This was really 997, wasn't it? So 997 times a -1 is a negative 997 over 1,000, right? Because there's 997 tickets that aren't going to win. All right, so I'm going to grab my calculator again. And let's add the numbers that are on the top. So we got 498 plus, or 499, I'm sorry. Oops, sorry about that. 499 plus 198 minus, because it's a negative, 997. So negative 300 over 1,000. Okay. should be equal to, so many equal signs, oops, a negative 0.30. Okay. So again, what does that mean? That means that on average, we're going to lose 30 cents for every one of those tickets that we get, right? Okay. Now there is a part B to this problem. Part B just says, what's the expectation if she buys 5 tickets? Well, the nice thing about that is all we got to do is whatever the expectation is that we buy 1, multiply it now by 5. So if she buys 5 tickets, on average she's going to lose $1.50, okay? On average. All right, let's move on to the next problem here. Okay, fair price. Fair price says determine the fair price, use the following formula. So fair price is equal to the expected value plus the cost to play. Okay, so here's our first problem. It says, at a game of chance, the expected value is found to be negative $1.50. The cost to play of the game is $4. Determine the fair price to play the game. Okay, so fair price is equal to the expected value plus the cost to play. So we already know what our expected value is. It's negative $1.50. The cost to play is $4. So the fair price should be $2.50. Okay. That's our formula. It's pretty straightforward. We'll come back to it in a little bit. We'll do another one with fair price in a little while. Okay, let's take a look-see here. It says new business. And in a proposed business venture, Stephanie estimates that there's a 60% chance she's going to make $80,000, a 40% chance that she's going to lose $20,000. Determine Stephanie's expected value. Okay, let's figure this out. 60% chance, 0.60. She's going to make $80,000. That's a profit of $80,000. Plus 40% chance. Excuse me. Whoa, sorry guys. That sneeze came out of nowhere. All right, 40% chance. I scared you. That she's going to lose $20,000. So because she's going to lose $20,000, it's going to be a negative $20,000. Okay. So now let's go ahead and multiply and see what we come up with. All right, let's see. 0.60 times 80,000 plus 0.40 times negative 20,000. And we're coming up with an expected value of 40,000. Okay. All right. Investment Club. The Triple L Investment Club is considering purchasing a certain stock. After considerable research, the club members determined that there is a 70% chance of making $15,000, 10% chance of breaking even, and a 20% chance of losing $8,500. Determine the expectation. Okay, this is similar to the one we did earlier. So 0.70 times 15,000 plus 0.10, breaking even is 0, and 0.20 of losing 8,500. So remember, if it's a loss, it's a negative 8,500. Okay. So I'm hoping as we're going through these guys, these problems are becoming a little bit more repetitive, easier to understand. So 0.70 times 15,000 plus 0.10 times 0 plus 0.20 times a negative 8,500, and we're coming up with 8,800 here. There we go. All right. Fortune cookies. Let's take a look here. It says, at Royal Dragon Chinese Restaurant, a slip in the fortune cookies indicates a dollar amount that will be subtracted from your total bill. A bag of 10 fortune cookies is given to you, in which you're going to select one. 7 of the fortune cookies contain $1 off, 2 contain $2 off, and 1 contains $5 off. Determine the expectation of a selection. Okay, so the probability that we're going to get the $1 ones, there are 7 out of the 10. The probability that we're going to get the $2 off, there are 2 of them, so 2 out of the 10. And the probability that we're going to get $5 off, there is 1 of them, 1 out of the 10. Okay, so now let's find our expectation. Okay, so we're going to take 7 over 10 times $1 plus 2 over 10 times $2 plus 1 over 10 times $5. Okay, so we already know that our common denominator here is going to be 10, so let's do that. That's going to be 7 plus, let's multiply those, that's going to be 4 plus, let's multiply those, that's going to be 5. So 7 plus 4 is 11 plus 5, excuse me. Okay, sorry. So let's see, 7 plus 4 is 11, plus 5 is 16. 16 out of 10 is the same thing as $1.60, right? That's roughly how much we're going to gain by doing this thing. Okay. All right. Okay, so the next problem here says, use the following statement to answer parts A and B. 400 raffle tickets are sold for $3 each. One prize of $600 is to be awarded. Winners do not have the cost of their tickets refunded. Okay, Raul purchases 1 ticket. Determine his expected value. Okay. So guys, remember, the probability that we're going to win, there are 400 raffle tickets, so there's 1 out of 400. The probability that we're not going to win is 399 out of 400, right? So if we win, the probability is 1 out of 400. We're going to win. Well, the prize is $600, but we did spend $300, or $3, not 300. We did spend $3, so we're really going to win. What is that? 597. Okay. If we don't win, the probability of that is 399 out of 400. We're going to lose our $3, right? So again, just like we did before, I know my denominator here is going to be 400. So 1 times 597 is still 597. What's 399 times 3? 399 times negative 3. A negative 1197. Okay. So if we add that to the 597, that gives us a total of negative 600. Okay, so negative 600 over 400 divided by 400 is $1.50 negative. Okay, so our expected value is to lose $1.50. Okay. Now, they're asking us to find, for part B, they're asking us to find the fair price. So the fair price is the expected value plus the cost to play. Our expected value was $1.50 negative. The cost to play the game was $3. So negative $1.50 plus $3, the fair price would be $1.50. Again, guys, all I did here was use our formula right here, expected value plus cost to play. Okay. All right, so taking a look at the next problem that we have here, it says, for the wheel pictured on the right, assume that the person spins the pointer and is awarded the amount indicated by the pointer. Determine the person's expectation using the spinner, assuming the spinner has not yet been spun. Okay. So we did something similar to this in the last section. One thing I want to mention is we want to make sure that we understand our probabilities here. So the probability we're going to land over here is 1/2. That's 1/4. That's 1/4. So guys, sometimes instead of me thinking about this as 1/2, I think about it as 2/4, okay? Just by doing that. And it's still $11 here, and it's still $11 here. Okay? All right, so let's find our expected value. If we land here, we have a 2 out of 4 chance we win $11. If we land in the aqua one, 1/4, we lose $5. If we land in the yellow one, probability is 1/4, we actually lose $22. Okay. So again, I know my common denominator here, guys, for all these problems is going to be 4, because that's my denominator. So that's 22 plus -5 plus -22. So it looks like, oops. So it looks like this 22 and that -22 will cancel each other out. That leaves me with a -5/4, which should be a -$1.25. Okay. All right. Let's take a look-see at the next one. It says, for the wheel pictured to the right, assume that a person spins the pointer and is awarded the amount indicated by that pointer. If it costs $3 to play the game, determine the expectation of a person who plays the game and then the fair price to play the game. Okay, so think about it this way. It costs you $3, but if you land on the red, you get $4 back, but because you paid $3, you really just got $1 there. Same thing here. If it's $5, but it costs us $3, well, we really gained $2. Okay, so let's find our expected value. Okay, we have half a chance to win $1, and we have half a chance to win $2. Okay. So that's going to give me 1/2 plus 2/2. That's going to give me 3/2, which is $1.50. Okay. Now we're going to find part B, the fair price. So the fair price is equal to the expected value plus the cost to play. So the expected value is $1.50. The cost to play is $3. So the fair price really would be $4.50. Okay. Alrighty. Let's try the next one here. It says, assume the spinner spins a pointer and is awarded the amount. It costs $3 to play the game. Determine, again, expected value, fair price. Okay. So remember, it's going to cost us $3. So I'm not really going to win $1 here. I'm actually going to lose $2 on those. And I'm not really going to get $4 here. I'm only going to get $1. And here I'm going to get 7. Okay. So let's find our expected value. Okay. The probability for landing on each of them is 1/4. So 1/4 times a -2/1 plus 1/4 times another -2/1 plus 1/4 times a 1/1 and 1/4 times a 7/1. Okay. Again, I know my denominator is going to be 4. So let's see, that's going to give me a -2, another -2, a 1, and a 7. Okay. So let's see, if I add those together, that's -4. If I add those together, that's 8. So that would give me a +4. 4/4 is 1. So my expected value on this game is to win would be $1. Now, we're going to find our fair price. So the fair price is the expected value plus the cost to play. So we found our expected value to be $1. The cost to play is $3. So the fair price should be $4. Okay. All right. Let's take a look here at the next one. It's kind of a long section, guys, but hopefully it makes sense. A person randomly selects one of 4 envelopes. Each envelope contains a check. that the person gets to keep. However, before you can get an envelope, you have to pay $10 to play. Determine the expectation if 2 of the envelopes contain $5 checks and 2 of them contain $25 checks. Okay, so envelope 1, 2, 3, and 4. Okay, 2 of them contain checks for $5, but it costs us $10 to play. So if I get one of those $5 checks, I really lost $5. Okay. The other ones have $25 checks, but again, it cost me $10, so I'm really only winning 15. Okay. So let's find our expected value. Okay. 1/4 times -5/1. A 1/4 times another -5/1. A 1/4 times 15/1. And another 1/4 times another 15/1. Okay. Just like we did before, I know my denominator is going to be 4. So -5 plus -5 plus 15 plus another 15. Let's see, that's -10 plus 30 over 4. That's 20 over 4. So my expected value is $5. Okay. Let's scroll on to the next one here. And let's see, it says there's a 20% chance that next year the total number of employees in the Staples stores in Milwaukee will increase by 300. There's a 70% chance that it's going to increase by 400, and a 10% chance that it's going to decrease by 5. Determine the expected value, or expected gain or loss in the number of employees next year. Okay. So 20% chance, 0.20, we're going to gain 300 people. 70% chance we're going to gain 400 people, and a 10% chance that we're going to lose 500 folks. Okay. So this should be 60. Let's see. This here should be 280, and this here should be a -50. So if we add those numbers together, let's see, oops, turn it on. 60 plus 280 plus a -50 leaves us with a total of 290 employees. Okay. Oops. All right. Okay. I think this is already, yes, there we go. Last problem. Okay. Let's take a look. Chipotle is opening a new restaurant. Customer estimates there's going to be an 85% chance the restaurant will have a profit of 200, 5% chance they're going to break even, and a 10% chance they're going to lose 30,000. Let's find our expected value. Okay, so 85% chance, profit of $200,000. 5% chance, break even, and a 10% chance that we're going to lose 30,000. Okay. Let me grab my calculator again, clear this out. So 0.85 plus 0.05 times 0 plus a 0.10% chance that we're going to lose how much? 30,000. -30,000. Okay, so our expected value is 167,000. And this, my section was, my friends, I'm sorry, this section was 11.3, okay? Hope it makes sense, guys.